In this video, we'll learn about quadratic equations with complex roots. Now, to begin with, we'll just remind ourselves of the generic quadratic equation. That would look something like ax squared plus bx plus c is equal to 0. Now, when attempting to solve this type of quadratic equation, the first thing we usually do is calculate the discriminant. And we write the discriminant, capital delta, which equals to b squared minus 4 times ac. Now, if delta is negative, the quadratic equation will have no real roots. On the other hand, now that we've studied complex numbers, it will have two complex conjugate roots. So I'll just write that. If delta is negative, then it has two complex conjugate roots. And the formula for these complex conjugate roots is the following. The first root would be x equals to negative b minus I times the square root of negative delta over 2a. And the second root would be x equals to negative b plus I times the square root of negative delta over 2a. Now, you may be wondering why it's negative delta under the square root. Well, the reason for that is because, remember, delta in this case is negative. So negative delta would become positive. So we still have a positive number under our square root in this formula. Now, let's go ahead and work through an example to see how this is done. We're asked to solve the following quadratic equation in C, the set of complex numbers. And the equation is x squared minus 4x plus 13 equals to 0. Now, the first thing we do, of course, is to calculate the discriminant. So delta, remember, equals to b squared minus 4ac. And in this case, we can see that the quadratic equation is such that a is equal to 1, b is equal to negative 4, and c is equal to 13. So using these values, we can see that delta is negative 4 squared minus 4 times 1 times 13. That leads us to 16 minus 4 times 13. That leads us to 16 minus 52. Finally, delta is equal to negative 36. So at this stage, we can see that since delta is negative, indeed negative 36 is negative, it must have two complex conjugate roots. And so to find the value of these roots, we're going to use the formula we just saw. So the first root would be x equals to negative b minus I times the square root of negative delta over 2a. And that would lead us to negative b, so b was negative 4, so negative 4, minus I times the square root of negative delta. Since delta is negative 36, that's negative 36, all of which is over 2a, so 2 times 1. That leads us to 4 minus I times the square root of 36 over 2. This leads us to 4 minus 6i over 2, and finally we can state that one of the roots is x equals to 2 minus 3i. And the second formula, we could use it right away, which states that x equals to negative b plus I root negative delta over 2a. But rather than going through that whole process again, we know that the second root is simply the complex conjugate of this root. So we can go right ahead and state that the second root is x equals to 2 plus 3i. And there we have it. So we have two solutions, and those are x equals to 2 minus 3i and x equals to 2 plus 3i. And so that's how we solve quadratic equations with complex roots. I hope that helps.